Happy Saturday, hackers. Welcome to Saturday Hacker Day. My name is Taggart, and today we're going to be taking uh, on some blue team challenges. I'm really looking forward to this one because it's been much requested to do some more Splunk. So we're going to be doing some more Splunk. But before we get to our main material, as always, at the beginning of the show, we're going to talk a little bit about this week in cyber news. Of course, my slides are still not updating, or they're doing so really, really slowly. But to kick it off, we have our first story is yet another 0-day in Mac OS. I can't even believe it, but we do have another 0-day in Mac OS. This one is really interesting for a couple of different reasons. The first is the vector. So there is an extension on Mac OS that you can use to open internet resources called .inetloc, INETLOC. And this allows you to access things on the web, or it will support other URL schemes as well. So file, as well as FTP and AFP if you're still using AFP. So a little bit dangerous, and it turns out that there are ways to use this file type, this extension type, to execute code on a system. So an email comes in, it has one of these .inetloc files as an attachment, you click on the thing, it executes code. Now, this is something this is similar to a .lnk vulnerability on Windows. The way that this was handled, though, is something that distinguishes it. So first, it has not been assigned a CVE by Apple, which is, in my opinion, not great cricket. The other issue is that they patched this 0-day, but only kind of. And the way that they patched it was by filtering these inetloc files for the file scheme, file : / right? But they only did so for lowercase instances of that scheme. So if you were to mangle it and mix lowercase and uppercase letters, the scheme still parses, but the filter doesn't catch it. Pretty elementary stuff. Apple seems to have missed it. Generally speaking, Apple's really good about their security stuff. This seems like a very odd oversight. Nevertheless, this thing is out there right now. I expect there to be a patch for it that fixes that oversight soon, but something to be aware of. And if you're interested in playing with it, you can check out some demos on how it works and how you could maybe use it to exploit macOS systems. We haven't talked a lot about exploiting macOS systems on this stream, just in part because virtualizing Mac is a little bit squiffy, but I definitely want to do some more of that in the future because I think it's an under-researched area. The other story that I wanted to talk about is this VMware remote code execution vulnerability. And you would be perfectly within your rights to ask, wait, which one? So this was released this week with a CVE of 2021-22005, described as an arbitrary file upload vulnerability in the analytics service. So that's part of vCenter server. Why does this matter outside of the technicals? So a couple things. First, this is unauthenticated remote code execution through a file upload vulnerability. That's one. That's bad already. But the other thing that's really concerning to me about this is that hypervisors do not generally have, which vCenter is, right? It's where your virtual machines are stored. Hypervisors do not have the same level of protections against malware as the virtual machines running on them. So in particular with VMware, right, we have seen ransomware attackers actually go after the hypervisors using the ESX CLI and other tools to encrypt the virtual machines themselves rather than trying to get onto the virtual machines and encrypt the virtual disk from within. And going that one level above gives them a lot more ability to do damage. So seeing a remote code execution vulnerability in a platform we already know is vulnerable to these attacks is quite alarming. There is a patch available for it, but it is just something to be aware of, that we have these continuing attacks against virtualization hosts. Quick sound check for everybody. How's everything sounding? Is it a little low? Can I make it a little bit better? Maybe how's that? Maybe a little bit louder there. Yeah, there we go. That seems a little bit better. All right. So today we are taking on some Splunk challenges. And we are, with Splunk, we are going to take on one of Splunk's own challenges from Boss of the SOC, or BOTS. And we've done some of this on the stream before, but I think what we're going to do, rather than kind of go through it as a challenge, is go through it as though we were an analyst in this organization and really talk about how we're using Splunk to surface this information. All right, thanks, Ogosoro. I'll turn it up a little bit more. I don't want it to peak, but I do think, yeah, there we go. I think that's a little bit closer to where I want it. I had to redo all my sound settings for whatever reason. Streamlabs just kind of like deleted all of my defaults, and so I had to rebuild my whole audio stack from the bottom up, which is a huge pain. So if anything's a little bit off, music's too loud. If music's too loud, mic's too low, just give a shout and I'll do what I can to fix it out. But I think we should be all right for now. Let's head over to our Splunk instance and get started. Okay. So I am in case anybody wants to follow along, I am in the intro Splunk room, which we actually started last Saturday. So we're continuing on that as part of our SOC Path. And we are going to go through the Boss of the SOC challenges. And it starts with a website defacement. So that's the first thing. That's kind of where we would begin our investigation, is our website has been defaced. And there's also ransomware. That's the second case. So the first one is going to be web focused, and the second one's going to be more endpoint focused. That's kind of how we're going to break these down. All right, so we're starting with a website defacement. That's where we begin. Now we'll have some questions to answer on these, but let's begin by taking a look at the Splunk server itself. I am here and I've done my initial query in Splunk. This is what I do whenever I get into a new Splunk server when I need to learn about what's going on. I do index equals star, so I'm pulling sources from every index. And then I am piping it to the stats evaluator and counting them by source type. So basically, I want to learn what's in this Splunk instance. What do I have access to? And how many events for each source type do I have access to? I care about source much more than I care about source. I care about source type much more than I care about source. Why is that? Source is another data point that you'll see from Splunk, but see, source is like the log path in a lot of cases. Now, sometimes they're similar, right? The stream IP, stream HTTP, but I actually care about the data classification more than the actual path. So that's why I go to source type. I want to see exactly what kind of data I'm looking at. And as you see, the stream source and source type are almost identical, if not completely identical. But I do care about IIS. I care about win event log, win registry, and this sysmon source type is going to be super valuable to me as well. You can also see, since I'm sorting by count but descending, that's what that minus is doing, I can tell that the biggest log source I have is in fact from sysmon. So that's going to be super helpful, especially when we get to the endpoint incident. And then I have Suricata and I have some stream HTTP. What I might do then, if I'm curious, is I might just get like the first few events from stream HTTP just to see what's going on. And notice that I'm at all time. I looked for everything in here, which pulled back just under 1 million events, which is, it sounds like a lot, but actually for Splunk, really not that big a window. But I am in smart mode, which means that I've only loaded the metadata for these events. That's why it was so fast. If I actually wanted to load all these events and see what they were kind of across time, I would have to go over to events, but you can see that my search did not return any events because I'm in smart mode. To fix that, I have to change it to verbose mode, or fast mode if I wanted the events without any parsing. But because this is under 1 million events, I'm going to take my chances with verbose mode just to see how it works out. And what I want to do here is look at, I don't care about the individual events just yet. What I want to look at is this tiny little time chart up here, because I want to see where the majority of my logs are coming from, what day or what time period. And it looks like most of the logs that I'm looking for are on in August of 2016. And because that's true, I'm going to stop this job. I'm going to click on that window, and I'm going to click on Zoom to Selection. That's going to change my time selection up here, but it's also going to make the query a lot faster because it doesn't have to look across all time. Now it's just looking for the specific range that I was interested in. One of the things that you're going to be doing a lot as a SOC analyst, and especially looking at a SIEM, is looking for spikes. Spikes means something interesting happened, and you want to identify the cause of those spikes. They could be totally normal, right? Spikes meaning increases in event counts. And you parse that a lot of different ways, whether it's from different sources, different users. But spikes means something interesting happened, and you want to figure out exactly what the spike cause was. Now here we have an obvious spike of events here, and we can take a look at my stats to again see what are my logs looking like. Okay, well, we've got a lot of sysmon logs here. We see more suricata information that might be interesting to see, network intrusion detection, some SMB stuff. Now it's also possible right now that we haven't zoomed in enough. Now, because we're looking at web logs for this first case, I'm going to change up my query and just look at my stream HTTP source type. So I'm going to stop this query, and then I'm going to add source type equals stream HTTP, and Splunk is helping me out a little bit with that. And now we're just going to get a quick view of what kind, how many events we have. And because I'm looking at a specific month, you'll see that I'm going to see another spike, in this case on August 10th, as opposed to August 24th. Now, the spike doesn't mean that all the bad stuff happened on August 10th versus August 24th, August 24th, but there's a good chance, right, that an attacker made a lot of noise. What are different modes? Can you talk a little bit about each one? Yeah, great question. So verbose mode, smart mode, and fast mode. Hey, Destroy Worlds. So fast mode is where I don't really care about the content of the searches. I really just care about the metadata, how many events I have in a specific source type or whatever. And it doesn't load or parse any of the information inside of the event. That's what fast mode is for. And I'll use fast mode first very often, especially when I have to deal with a lot of data, right? Once I get up into hundreds of thousands of events, now I'm really talking about working some processing muscle. I want to make it easier for the indexer and the search head to do what they do. And for that reason, I will use fast mode. Smart mode is activated automatically for things like doing charts and doing stat searches. And that's because it knows, like, oh, okay, I need to pull some data here, but not everything, and I won't show you the whole event. So when you're doing charts or other statistical analysis, you'll end up using smart mode for that. And then verbose mode is the whole smash. It loads everything. And I will say that most of the time I'm in either smart mode or verbose mode, because I will quickly exit the need for fast mode because I will identify where in time I am looking at my investigation. And once I filter down by time, I am getting rid of so much noise that I no longer have the need for fast mode. And I like having the flexibility of looking at the full event when I need to. So I tend to hang out in smart and verbose mode. All right, so let's take a look at what we have for stream HTTP. And we're looking at, let's zoom in further to August 10th. When we zoom into a single day, we'll get an hour breakdown, which is really, really handy. And again, you can see this. There's this spike at 10 p.m. A little bit more at 9 p.m. Okay, so we'll zoom in further to just there. We'll zoom into that selection. So it looks like this is when things went down. And once we zoom into those 2 hours, you can see even more detail. Look at that. So we see like there's 1,500 events at 9:37. Now, just looking at this might be nothing, right? This could be some average user because I don't know what other baselines are. But I will say, one thing that I always keep in mind when I'm looking at this kind of data is the concept of the standard deviation. It's a statistical thing. Chat, we have a lot of folks here. Welcome, everybody. Does anyone want to take a stab at explaining standard deviation? So standard deviation is a measure of variance. And you can take a look at these formula for it. Don't worry though. There's a much easier way to understand it. It's the square root of its variance, and variance is actually super easy to understand. Basically, without going into too much specific math here, let's take a look at our data and think about this. Look at these values like every minute of how many events we have, right? We have a certain amount every minute. Now, across time, there's a difference for every one of those samples, right? Whatever that count is per minute, right? So at this minute, I had 671. At this minute, I had 576, 475. Okay. So what I'm looking for is essentially from point to point, the average difference, right? And then that's my variance. Square rooting that becomes my standard deviation. It's this value to indicate like how much weirder a certain value will be against the norm of my set. And we will often use the Greek letter sigma to represent the standard deviation. So what I'm looking for is once I have like a basic sense of this, and I could do some real math to look at it, but you could start to eyeball it, basically like 1.5 times or something like that, whatever the standard deviation is. If I see, whatever the normal kind of jitter in this line is, if I imagine that as a size, and then I think, okay, like 1.5 or 2 more of those above it, that's starting to become what we would consider significant statistically for something that's outside the norm. And so if I look at these 2 bars here, like these guys are chunky. So I want to know what's going on here because they're so different. Yeah, I think people hear standard deviation, they see those formulae, and they're like, oh God, what? But it is actually a pretty intuitive concept. We just need to put real numbers to them so that we can measure them. All right, so we're looking at this. This is really interesting. I don't want to zoom into it just yet, though, because the attacker might still be doing stuff here. I don't know for sure that I've identified what's going on. I know there's something a little bit weird, but I'm still in sniff mode, right? I'm still looking for what's going on. At this point, my next thing, actually, I'll ask you, what do you think the next thing we should maybe check out is? Or how could we dive deeper into this data set? Something I like to do is run a time chart, which gives me a much better visualization. Time chart count by, and now I have to look at my data. What fields do I have in my HTTP stream? I have a destination IP, and I have a source. I should have a source IP somewhere in here. Yes, I do. That's weird. So I want to start by looking at what's coming into the house, right? How do things get in? And then maybe I'll look for outbound. But the first thing I want to do is look for what's coming into the house. So I'm going to time chart count by source IP. And what that will give me is a really nice visualization of what was happening or what was coming in from different sources across my time window. And I'm going to clean up this chart a little bit. The first thing I'm going to do is I'm going to change it from a column chart to an area chart. I like that better. You know, I like a continuous series rather than these discrete bars. That helps me tell the story. I'm also going to get rid of the null counts. We have some that don't have a source IP for whatever reason. And we're going to say use null equals false just to knock that out. Okay, so we have a pretty obvious suspect here. Because look at the other values we have. We have 192.168.250.100. That's some source. These also look like internal IPs. But external, look at this. We have this one IP, 40.80.148.42, making more noise than anything. That's really, really interesting. We also have this 23, 22, 63, 114. So we have two IP addresses that we might want to check out. And it's at this point that I, if I'm doing this correctly, should be taking notes. So let me fire up my notepad here. I use Joplin. So we're going to look for interesting source IPs. And what do I have? I have 192.168. Nope, wrong. 23.22.63.114 and 40.80.148.42. I should also indicate the time scale I'm looking at, right? So I'm looking at, I'm going to just copy pasta this right here. So over the course of 2 hours. It's a really nice, discrete time window. I appreciate that. So we have two interesting IPs that we want to dig on a little bit. 23, 22, 63, 114, and 40, 80, 148, 42. As almost just like a muscle memory thing, something that I might do with these IPs now that I have them is go check them against some threat intel sources. So I might check these against VirusTotal or Cisco Talos. All right, that one looks clean. And also, I mean, these are fake, so you never know. But this is something that you should do. You should check your sources against threat intel, just in case they're known. Gray noise is also really great for this. All right, doesn't know about these IPs. So remember that absence of evidence isn't evidence of absence. We can't verify that they're not evil because attackers come up with new IP addresses all the time, but it's not a known malicious, right? So we still have more work to do before we start saying, hey, block this, like what's going on. So now we have to figure out exactly what's going on with each of these sources. At this point, this is where I start making tabs. I'm going to duplicate these tabs because I'm going to have one for one source IP, one for the other. And because they are named the same, I came up with a a piece of code, which is a browser extension called Titler. And what Titler does, I have it installed right here. It allows me to just change the titles of tabs. So for this one, I will change it to the second IP. See that? And then here for this one, I will change it to the first IP. Now, I don't have to guess what my tabs are doing. I just have the titles right here. Question, VirusTotal is enough for threat intel or you use other tools? No, it's not enough. VirusTotal is one that I would use. If I were doing this at work, I would have access to, premium cyber threat intel feeds, and I would run these against those feeds. But you could also check things like Alien Vault, Open Threat Exchange. You could Cisco Talus is good. Gray Noise, as I showed you. There are a number of them that you can check. VirusTotal is good. One thing that's nice about VirusTotal is that you see that it does aggregation against multiple sources, but especially for IPs, you want to go against more than one. Does Mandiant Advantage, do they have a free tier? I don't think so. They're a good one. Weird. Okay. So we have these two IPs. Now let's actually build out the queries to look at these. So now I want to go back to, remember that we have the events here. And I want to use interesting fields from each one of these. So I want to know, what are they asking for? So I'm going to ask for the request here. And so I'm going to add the source IP equals and make it 23.22.63.114 in this case. And then I'm going to change this up from a time chart to stats again, count by request. And I'm also going to pipe that to sort minus count so that I'm looking at them in descending order, just to see what's going on. Okay, interesting. So we're accessing Joomla. Let's take a look at this one. So we're going to reproduce that same query, except we're going to change the IP. 40.80.148.42. Now I could have done this with an OR and done the same query for both, but I like keeping them separate just because I might dig differently on these different IPs. All right, so let's see. Let me go to statistics. Interesting. So they're accessing a lot more requests. And what are we looking at here? We are looking at a brute force scan against our website. JBoss, it doesn't, it's being naive about the kinds of things that are on our server. So this is a straight up scan, right? It's looking for Docker file, all this stuff. It doesn't know what it's looking for. It's just running like a word list with dirbuster or Ferox buster or something like that. And as a matter of fact, something that can be very, very revealing is looking at the user agent. So I'll just come down to my field here. I should have user agent in here. Do I not? HTTP user agent. Yeah, there we go. HTTP user agent. So what are we looking at? The user agents are getting mangled. That's an obvious sign that they're trying to do some sort of injection. All right, so this is a bad guy right here. Let's take a look at what we have going on here. Now we have a lot of these Joomla administrators. This could be legitimate traffic so far. We don't yet know that that's evil. A lot of different user agents. That's pretty weird, right? If we have a single source, but we're seeing 100 plus user agents, that's bizarre. And right here, the Python URL lib, somebody's running code against us. So that's pretty bizarre too, especially because it's so many of them. So that's a little bit interesting. So both of these look weird to me. This refer also looks a little bit weird to me. So I have both of these. They both appear to be pretty odd. Which one came first then? Which one came first? I'm going to get rid of the stats, and instead I'm just going to say to reverse. So I want to see the first one first, right? Because Splunk gives them to me in descending order. So this one happened at 9:45. Always think time. Always think time. And by the way, we should be taking notes here. So 23. So 23, 22, 63, 114, their first event was at 9:45:09. And we'll do the same thing here. What's our first? So this one is at 10:21. So this was way later. Or not. It's just searching back. Never mind. Okay, so 10:05. So 9:45 to 10:05. So we're talking about 20 minutes difference. Yeah, you saw an XSS attack. Yep. They're gonna, the brute force scanners, right? If they're using Zap or Burp Suite or something like that, or if any kind of fuzzer, they're gonna throw all kinds of noise at you that give away the game. So we have these two IPs. They both seem to be doing something interesting, but the first one was from 23, 22, 63, 114. So that's the one I'm gonna kind of put in for our answer here. It's like, what is scanning our web server? Oh, they actually, sorry, they wanted what IP is scanning. The scanning is the 4080. So what web scanner scanned the server? So for that, we would actually look for our HTTP user agent here. This is it, Acunetics. They were using the Acunetics scanner. And what is the IP address of our web server? Where were they going, right? That would be the destination IP. And so obviously that's going to be 192.168.250.70, which we're just pulling out of this field here. I use these side fields very often just to get like a raw count quickly without having to run extra queries. What content management system is I'mNotReallyBatman.com using? That's our site. And what were they using? Well, we know based on these requests that this was Joomla, right? What IP address is performing the brute forcing attack against our website? Okay, so that's the one we found here. Actually, I feel like that should still be 40 because of the requests that we found. Although there may be other brute forcing. Oh, you know what it is? It's not, okay, so brute forcing not in terms of directory browsing, but brute forcing in terms of let's see what else we do. We have post body. It's the destination content. I don't want destination content. I want headers, HTTP method get, source headers, URI path. Let's take a look at just post requests. So we're going to say HTTP method equals post, and I'll just add that to my query just like so. Okay. And then we have content length, content type, source content. That's what I want. So for this one, I'm going to not do a stats. I actually just want to do a table because I want to filter down to just that. So table time source content. So what I'm doing here is I'm looking at the timestamp because I want to know what time it happened. And then I want to see what's happening here. This is the source content. This was what was sent to the page. And actually, let's add URI in there as well. Most of these should be to the login.php or administrator index.php, right? Because that's where Joomla logs in the admins. Look at this. So the username equals admin. They're leaving that alone, but look at what's going on here. The task equals login. That's fine too. But look at what's going on with password. They're firing everything under the sun at this. So, baseball Mustang. This looks like Rock You to me. So, this is definitely the brute forcing attack that they're talking about. Now, do we have status? We have status 303. Splunk, what query language is in use? Splunk uses its own query language called Splunk query language, which is confusing because that would be SQL, but it's not. It is its own thing. What was the first password attempted the attack? We actually got this for free because we already did the reverse. So if we go over to our statistics table, we can see that the first password was 1, 2, 3, 4, 5, 6, 7, 8. Yep. That's a super important one. Just remembering to flip your order so that you're looking at things in a rather than reverse chronological. You want to start where the story began and work your way down. If it seems like I'm harping a lot on time, that's because as an analyst, especially when you're in the thick of an investigation, it's very easy. I won't speak for everybody, but at least for me, I find it's really easy to kind of zoom in on the technicals. Like, oh, what was this? What was this? Where did this happen? And remember that your job is to figure out the whole story. And so time is your framework. It's the scaffolding on which you have to put your technical evidence. So if you forget about time, you're going to miss stuff. What about QRadar? Does it also use special language? You know, I don't have a lot of experience with QRadar, but I do believe that it has its own query language. Yeah, most of them do, right? Even ElkStack uses its own. Thank you, Token Satori. Arial query language. Neat. One of the passwords in the brute force attack is James Brodsky's favorite Coldplay song. Which 6-character song is it? I'm pretty sure it's Yellow. Okay, but let's say we didn't know Coldplay songs, which would make you a good person. And let's say that we wanted to find that out. This is where we really start getting into the use of regular expressions. So to do that, I have to do something called rex. And what Rex does is allows me to use a regular expression to extract data from a field to create a new field. And this is kind of the starting point here. The field we're going to search is not raw, but rather the source content, right? And we're going to search inside. Actually, this isn't what it looks like at all. We're going to look for password equals, at which point we use what's called a capture group. What do I prefer, investigating with query or filtering? It depends on what I'm doing. I'll use queries to get data back and then filtering once I find more things to get specific on. Investigations are not linear. You're not going to go down and down and down and like find the one thing. That's really not how they work. You're going to be going up and down all the time, zooming in, zooming out, moving laterally. So you really have to be flexible, and that's why I often have multiple query tabs open so that I can move between them. And that's also why I made this extension so that I could name the things, because Splunk is really, really bad at that. They all just say search, which isn't helpful. Okay, URI, source content. Okay, so we're using what's called a capture group here. And a capture group will take part of the regular expression that's getting matched and name it. So what are we naming this thing? We're actually naming it, we'll call it password. And what is inside the capture group? It's whatever happens, it's one or more characters of any kind. That's what the dot means, one or character of any kind, and the plus means one or more. And after it comes an ampersand. So on the left side of the thing I'm trying to capture is the password string, right? Then comes my password, and the thing that delineates it it might be just an equals sign. No. Password equals let me in. Ampersand. And we'll do an optional for that. And we'll see how we do. So we'll do table source content. Let's put password in here, because now we have a new field getting generated by this regular expression called password. And we can add that to our table. And actually, let's get rid of URI. It's not helpful, because they're all to index.php. See that? Now, this didn't capture everything exactly. If I wanted to be a little bit more specific, you see how it caught this like extra parameter in here. So obviously I need to be a little bit more specific. The ampersand was an optional, right? It can be there, it doesn't have to be, but either it's an ampersand or it's just the end of the request. So what I'm going to do is I'm going to say ampersand or, and then the symbol for the end of the line, which is the $sign. That should do a little bit better for me. Yeah. Although this one, the password was like, didn't catch all of these. Hey, Tiny Witch. Yeah, get your stuff done. My entire career is telling people to do their homework, so I'm not going to begrudge you doing your homework. But it's very good to see you too. All right, so that could have done a little bit better. I actually want to go back to my optional capture there, because at least that gave me some better data. And that's just the irregularities of the submissions. You're using jQuery for the first time? I wish you all the fortune, and I also wish you to discover how to never use it in the future. Do we see only those passwords go over HTTP? That's a really good question. And the answer has everything to do with how our networking is set up. In this case, it is HTTP. So we're capturing it from, but the issue is like, where is it coming from, right? What I believe is happening, since we're pulling inbound data, is that we are essentially using a reverse proxy to capture the inbound HTTP requests, and we're reporting that out. That being the case, a reverse proxy could decrypt the HTTPS inbound and forward it on and capture that data as well. So depending on how you're capturing the data, you could see the HTTPS requests as well as the HTTP. Now, quick aside on proxies, right? What you would have to do to make that proxy work is set up the certificate correctly there, and then set up a certificate trust between the proxy and your HTTP server so that all of that looks right. And if you were going to do an outbound proxy, the way that most folks do, or most organizations do inside their network, if you want to be able to decrypt the HTTPS traffic, if you want to be able to see the HTTPS stuff going out of your network with your proxy, you have to deploy a certificate to all of your endpoints that essentially says that, oh, your proxy is a trusted root certificate authority. And that allows you to use your own cert to essentially, what you're doing is you're monkey in the middling your own traffic, right? It's like an attack, but on purpose. And you are trusting the certificates of everything else on the other side. So that's how you decrypt TLS SSL traffic using a proxy. And I think it's going to become more and more common as more stuff goes over HTTPS. I mean, we're almost at what, like 98% of the web is now over TLS SSL at this point. But there is another kind of traffic that is about to see a lot of use in on that protocol, which is DNS. And DNS for me is a huge source of data. So if we move DNS over to an encrypted protocol, I know for sure organizations are going to want to be able to decrypt it and look at that DNS information. It's too valuable to leave invisible. All right, so we have this password stuff. That's really interesting. Now, I want to make sure that the status codes, see this 303? There's only status code 303. Test haters 303, location administrator index.php. Okay. Let's see. Let's look at dest content quickly just to see if there was anything. Yeah, it looks like there wasn't a whole lot of success here. It just kind of looks like they were brute forcing. I don't see any successes yet, but also remember that we would see, like, in terms of URI, we would say, let's go back to our statistics. And we're actually going to get rid of the reverse for this because I want to see the last stuff that they got into. Meaning, let's assume that they did crack the password. Were they able to get in? Okay, so it looks like, yes, they did. And so let's look at the URI. Oh, I'm going to do just kind of a where match. This is kind of if I have a fuzzy match, I'm going to match URI index.php. And change it to post. And let's see what we have there. Let's just go that far. What I'm looking for is the last password that they tried, right? To see what was the one that they got in with. So rock looks like the last one we saw there. And so we could try to see if the password equals rock, right? But oh, what's the correct password for admin access to the content management system running I'm Not Really Batman? So here it looked like rock, but because the last one that we saw was that, but maybe that's not correct. Hello, Phaetonal Porter. Good to see you. Problem is that all of these are redirections. They don't actually. Let's change it up a little bit. Once they had the right password, they would have gone in with a different user agent. So let's. We only have Python. Okay, never mind. Actually, Hoda. Because remember, this came first, right? And then came this one. So oh, it would help if I spelled method correctly. So this is to I'm Not Really Batman.com. Security check. So see here, we've got 303s. We're getting redirects. Let's see some 200s. That's what I wanted. And oh, I want to look at this not in reverse, right? I want to see the. And let's look at our URI, because the URI is going to be There we go. Index.php. And in this case, I am going to actually, let me change that up. Because it looks like we had a URI for actual login, right? So let's take a look at that. Login task equals user. Nope, 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 nope. I want this one. I was in the right place, but source content, not form data. Interesting. So there's no 200s. Let's look for there it is, right there. This was our first event from this one. So the password is Batman. What was the average password length used in the password brute forcing attempt rounded to the closest whole integer? Wow, that's something. What was the average password length used in the password brute force? So this was our brute force, right? This is where they did this. Let's go back a couple of queries so we have that password, and let's actually try to sort this out a little bit better. Password equals ampersand equals or the $sign. Is it, do I have to escape the ampersand? No. Do I have to be more specific about this? Do I have to do character sets? Or can we write query as failed password? No, because the failed password gave us a redirect. The content actually might have given us that as well. It's possible. I really hate parsing through giant HTML when we have other metadata that can give us the story. But it's not a bad idea, right? If the destination content said incorrect password or something like that, that would have been a good tell as well. We actually let's try that, but let me fix this first because we still have to get the password out of this thing. So password equals we're gonna say A to Z, and then underscores and stuff. No, because then we're going to basically be doing, let's try it this way, not ampersand equals or the end of the line. We'll do a negation and see how that does. Better. Oh, regular expressions. Oh, hey, we got it. That's better. Okay, so with the password parsed correctly, what we can do is do average of the length of password. That should work. Or not. So what we're doing now is we're using the eval to create a new field. You see we have the password length. StreamStats is crazy. So what StreamStats does is it creates a running query of the average. That's not actually what I want, but I wanted to show it to you. So what it'll show you is the average as it goes. As it goes through each event. So if I wanted to, actually, this will just do it, because if I take out the reverse, the last one, right? Unless they're not chronological. They're by. Just kidding. So this is annoying. But actually, if I get down here, the stream stats will tell it to me. So the average is what? 6 dot rounded to the nearest what? Whole integer? So the average should be 6. Math. So what is stream stats doing? Stream stats, this is like a really kind of accounty thing that you'll see often, which is a running query or a running total, meaning that as new data comes in, this field is going to get updated to represent the new data that you've provided to the field. So at every point for each one of these as they come in, this average is getting recalculated to represent what this thing does to the average. This is really, really, really interesting. And stream stats is super revealing in terms of what impact individual events can have on certain statistics. So, for example, let's say that I had a bunch of like SSH or FTP or SMB connections. Let's say I had a bunch of those. And I wanted to know like what individual events contributed to the average. Well, what I could do is I could use stream stats to run the like the average total bytes or something like that that were getting transferred. And then I could actually do a calculation of like how much the average changed from point to point, which would indicate the impact of any one connection. So that would highlight for me what are my biggest contributors to my transfers. That's really good for surfacing exfiltration. And by the way, and for those of you who haven't heard me say this before, I'm an English major. I don't. This kind of math is not intuitive for me, and the reason I mention that one, to own up to the fact that I'm certainly capable of making mistakes here, and I have no ego about that whatsoever. But also, if I can do this, you absolutely can do this. This is not something that requires a certain kind of intelligence. It doesn't require a whole bunch of special schooling. Like, you can figure this out. You can. Um, it's just about learning how this makes sense to you. I really, people are told or learn to say when they're in school, "Oh, I'm bad at math." That's not a thing. Um, there can be some sort of talent for it, but everyone's quantitative reasoning develops at different paces. And what frustrates me so much about our formal schooling system is that if you're not, like, if you can't quite grasp geometry right when they're teaching it to you, or even about how they're teaching it to you, you internalize that you are bad at it. That's not at all how this works. And so if you've ever struggled with something back in your educational history and you wish that you could do it again, give yourself a chance, revisit it, and see if maybe another approach, or even just with the added time, you have developed new capabilities for these things that you didn't know that you had in the first place. That's certainly been my experience. How many seconds elapsed between the time the brute force password scan identified the correct password and the compromised login rounded to 2 decimal places? So basically, we're talking about Bitcode. Thank you so much for the follow. We're talking about when did the brute force find the password. So we're going to just do on this one, we're going to say we're just going to search for password equals Batman. We're just going to search for that string. Happened one time at 9:46. And then we're going to look for the same thing here. And we're going to reverse to look at the first time, because presumably, get rid of that URI. Oh, wait. Password, not password. There we go. So this was 9:46:33 to 9:48:05. I hate doing time math. To the point I was just making. .4603. So 46. 60 seconds gets us to 47:33. And then let's do just 32. So to 2 decimal places. 689. So how many? Sorry, let's try this another way. So it's I really like using like Python for this. There we go. So we'll say T2 equals datetime.time. And we're going to do the hour, which is 9 minute 48 seconds 5, and then the microseconds, which is 858. And then we'll say T1 equals datetime.time 9:46 33 689. That's not right. 689. T2 minus T1. Wrong. T1. What? Let me see. I know there's a way to do this. Oop. Oh. Okay, so the problem was that I needed to turn it to a date time, not a time. I need learning a new software. We're moving to QRadar. What are your advice for style for sorting? Hey, GoPro. Um, so the first thing that I would do if you're learning a new sim is get yourself a test environment, right, wherever you can. And I would go through the official documentation and don't skip. Don't skip. Read it basically cover to cover. Take your time with it. This is a secret superpower. If you read documentation thoroughly, you become legendary. You will know things that people who didn't do that don't know. It's important that you take that time. It's slow time, but take it. That's building your foundation. That's where you begin. And if you don't, process documentation super well, or there's a language barrier, and videos do the same thing, like that's fine, but take your time, learn it from start to finish. And then once you have that done, you need to practice, because what you need to discover next is you don't know the right questions to ask yet until you start doing the practice. Once you practice, you will have new questions, at which point you can either refer back to the documentation or find other sources. But you have to start from that kind of more formal beginning, because that's what's going to lay the foundation for where your next jumping off points are going to be. There's a concept, some of you may have heard of this, that it happens a lot to programmers who are trying to learn from online sources, called tutorial hell. And I found myself in tutorial hell a lot of times, where it's like how to Tiny Wish was talking about jQuery. It's like, so how to build a basic web app in jQuery. And like you'll read it and you'll say, okay, I think I understood that. And then you won't be able to put it into practice. Why? Because there's a disconnect between the form and the intention of tutorials like that. This is a tangent, but it's worth talking about. Yeah. Bear with me for a second, friends. This is a really important idea in teaching. How long does it take to learn a SIEM? I cannot answer that for you. No one could answer that for you. There is no answer. It takes as long as it takes, and you don't finish. How long does it take to become proficient? I can't answer that for you either. I don't know how you learn. I don't know how you practice. The more you practice, the faster it will be. That's all I can say. Here's the problem with tutorials. Even what we're doing today. If we think about the kinds of learning as a pyramid going up to like the most complicated versus the simplest down here, right? It's like, oh, you can like memorize stuff. That's basic learning. It's the kind of stuff that we actually don't have kids do a lot of anymore. Folks my age from the United States might remember that we had to memorize state capitals. They don't really do that for kids anymore because why would you? You can look it up in a second. This is rote learning. This is not super interesting. And this is the kind of stuff that really you begin with. But the reason why you memorize some things is because you want to not have to think about it later, right? It's stuff you want to be muscle memory. Then if you can understand it and you can communicate it, right? That's the next level. And this is right here where tutorials tend to live, somewhere between these two. They're making you do this and they themselves are doing this. Problem is that there is no way easily that tutorials can get you from here to here using information in new situations. In order to do, you cannot read a tutorial and then immediately go apply it unless you have a super firm foundation here. And even then, you're going to get stuck the first few times you do this. And that's okay. That's understandable. Getting stuck means that you have new questions, that you have to go back down here to learn new stuff. Then you can get up here and start learning new things. Once you've internalized that information, you can start climbing up and up and up. So that's kind of why tutorials can be frustrating in that way, and why I don't recommend tutorials as the starting point for a lot of things. Good morning, Oreo Bite. All right, back to Splunk. Hey, Monimo. You're quite welcome. If you're interested in more of that pontificating, I am speaking at ShellCon on October 8th on basically how to use ed theory to become a superpower, or how to become a superhero in tech. Oreo, that chart in your mauling over Windows. Yeah, and did you notice did you notice that the top of this pyramid was create? This indicates that you've really mastered something. Really, really important. And I would also say that I saw another version of this where I'll try to find it. I wrote this article years ago that basically was like gamers actually do this as well, where they begin learning how to play a game, then they start like explaining it to other people, or like really like breaking the game apart and understanding the metagame, things like that. And then all of a sudden they start creating new content, or they build a community around the game. Then that's kind of the top level of that as well. I think it was I read that originally about the game Spore, which had this creature creator and some other cool stuff that lended itself to really interesting research into how people used the game as a medium. Yeah, I used Spore in my classroom as an English teacher actually, because I had kids journal about their story from single-celled organism all the way up to like spacefaring civilization. It was cool. It got kids really invested. Okay, theoretically, we're doing Splunk today. How many seconds? Oh, right. We're trying to figure out date time. So I hate doing time math, and I want Python to do it for me. So we're going to have Python do some date time math for me. To do that, I have to use the date time constructor, where I give it the year, month, day, hour, minute, second, and microsecond. And so goes a little like this. I'm going to make T2 date time dot date time, and the year is 2016. The month is August. The day is 10th. The nope, yes, and then the hour is 9. The minute is 48. The second is 5, and the microseconds are 858. Then T1 is going to be something similar. T1 is going to be mostly the same, except that it's 9:46. The seconds will be 33, and the microseconds will be 689. Now T2 minus T1 is 92 seconds, 92.169 seconds difference. Whoa, Mimo, first of all, kudos to you. You've successfully onboarding a replacement is a hard task, so congratulations for doing that, and I'm glad that they had a good experience. That's definitely, that's all you. If I gave you some tips, that's great, but no, give yourself the kudos you deserve. Okay, so 92.169 seconds. So that'd be like 92.17 seconds. Ah! 2.17. We did a math, everybody. Or rather, Python did. So what we did was we imported the datetime library from Python, and the datetime.datetime object allows you to just kind of put in all the parameters for your time. And then that allows you to do mathematical operations. And what it returns is this thing called a time delta, which will contain the information you need. So if you ever really need to find durations and you don't feel like mentally doing that math because it's a huge pain, I strongly recommend Python for ease of use there. Okay. How many unique passwords were attempted in the brute force attempt? So again, we're going back to our brute forcer here, which was, isn't Chrome console better? Elliot Anderson. It depends. I don't love date objects in JavaScript. They're somehow worse. And so I don't rather than creating, because like if we look at the JavaScript date, and by the way, let me just quickly say that there's no better. It's whatever you're comfortable with. So I guess you can do a date like this. But what you to do the delta, you'd end up with a, I don't know if you can do the math between the two. Let's find out. So we'll do var d1 equals new date. Okay. And we'll say var d2 equals new date. Yeah, so we get back the like number of milliseconds, which I guess we could just like divide by 100. That would have worked out okay. So yeah, not bad. I tend to think about using Python as my support more than the Chrome console, but yeah, good point. So now we are asking for, no, it didn't. Oh, the Windows event log stuff? Yeah, there was a lot going on there. How many unique passwords were attempted in the brute force attempt? So we have our passwords. And we're just going to do stats count by password. Nope. Well, 412, I think. Yeah, there were no repeats in those events. Okay, so now we're getting to someplace totally different. So we figured out this brute forcing is kind of like we're done. We figured out the brute forcing. Now we need to see like what was actually going on with our logged in user. And so what we're going to do here is we're going to do table source content to see everything that was getting uploaded. And it's going to be a lot of stuff, I presume. Yeah, that's not super helpful. What I might do is actually form data here rather than source content. How did I know the 412? Look right here. Because I did a count by password, I guaranteed that each of my results was going to, I was going to make each row kind of aggregate unique passwords if there are similar passwords if there were any. So because I got this result back, I had 412. Cute. So it's a lot of like garbage. I don't think this is where we want to be. I don't think this IP address is helpful here. Let's go back to our 2322. I think that I think we still might be here with this this IP address. And let's get back. This is again a zoom out where we're gonna go and look for just all of our posts, and let's see. Not form data. The form data and source content are very similar. Let's do table form data just to see what's up. And we're looking at the... So this is... We're still just looking at the password brute force here. I think we need to zoom out again and just actually go down to stream HTTP. Method equals post. And we're going to do a time chart count by, need a pipe there. So again, you see how we zoom in, we zoom out, right? By source IP. Let's go to visualization. So we obviously had our password, the password brute force was from 23. We had like one event from 250.100. And then we had this directory brute force here from 4080, 148.42. I want to rule out, now that I feel like I have a sense of what was going on with these other two, I want to take a look at this third IP address. I want to see what was going on with that. 192.168.250.100. So I'm going to actually duplicate this again and once again use my titler. And change up this IP. Let's take a look at what was going on here. Two events. See here? This is what I'm talking about. Upload data.aspx. No, but this isn't us. This is some other thing. They weren't uploading to us. So now I'm going to clear out the source IP entirely. And use another... Yeah, we're going to say site, I'm not really Batman.com. Well, that's pretty much everything, but we'll... Okay. Let's look for upload. And let's also filter down to the site. Oh, we're there. Cool. Let's filter back to 40.81, 48.42 is our only. So that's good. That's the destination content. Let's look at our source content. You see how big this is? That's why we don't like doing this. Okay. Agent.php. Look at this. That's malware. Okay, so we're going to do just like a table source content for this. And we'll add the source IP back. Actually, we don't even have to. It's already filtered. Oh my. And let's also actually pipe this to reverse so that we see these in chronological order. And we'll look for the timestamp as well as the source content. So what did you do? right? So Akinetics test, 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 test. Then they finished their test. Test was over. Now they're doing real stuff. And actually, I'm curious about the URI for each of these. So let me add that into the mix too. Aha. So after that came the COM installer, name install package, agent.php. Here's the PHP code. And create function, cout, cout, maybe count. This is going to come into play later, I have a feeling. Basically, we're going to be looking for weird stuff based on the refer, which you'll see. So here's what's crazy. Install directory, c initpub www joomla temp install URL. So the first thing that happened was agent.php. This was the thing that got uploaded. Now, we stop seeing traffic because it's no longer HTTP method post. What happened next was not a post. Do we need to send these logs to CyberChef? Maybe. This is really, it's not encoded really, it's just annoyingly obfuscated, but not enough. You can really see a lot of what's going on here. And as a matter of fact, we're going to see the result of it in a moment. So what we're going to do now, let's actually capture this though in a screenshot. Let's include the timestamp in that. Back to our notes. Because this is the first time we've seen like a payload get delivered, right? And now we want to start looking for agent.php. So we're going to now look for requests, get requests to this might work, it might not. So when I don't know exactly what it's going to be, but I know that agent.php is going to be in there, I'm going to, instead of doing equals, I'm going to do a where match URI agent.php. So it's a regular expression match. So I'm saying, okay, if this thing is inside of the URI field at all, go find that for me. And plainly, that returns data. And I'm looking at these in chronological order. This is going to be super interesting. And this actually is why I was talking about. So agent.php and chat, does anything look weird from what we're looking at already? If you said that it was the refer, you would be correct. This refer is super weird. Very strange indeed. There's a lot of data in here. And we can try, we can try to do stuff like put this into it might be just base 64 encoded. No. So there might be other stuff going on with it. But plainly, something's going on with /agent.php. And this dest content is pretty interesting too. So it's just bytes. What I suspect we're looking at is, you know, a web shell of some sort that's totally obfuscated. But also, let's remember, let's actually go back. And find that malware that we had again and see if we can understand a little bit of what's going on here. Create function, session, string to lower. So it's very, very obfuscated, right? What was the actual question? Question was, what was the name of the executable uploaded by Poison Ivy? Is it agent.php? No. So we haven't found everything else that's going on yet. Here's the trick, though. At this point, we now may be looking outside with agent.php. We may be looking outside of HTTP, right? So we have the refer, but the agent.php, we're seeing command and control, but we may not be seeing everything else going on. So with that in mind, we're going to actually change this up a little bit. And we're going to get that source IP, and we're going to start searching across event source types now. Rather than focusing on HTTP explicitly, we're going to focus on source IP equals. So nope, I wanted 40. Oh, I guess I didn't. I guess I wanted the 23. Yeah, of course I did. And we're going to see everything that is happening. Look at that, 9,000 events. So, and over 5 source types. So we have Suricata, we have Stream TCP, we have Stream IP. Let's look at the Stream TCP rather than the HTTP, because I have a feeling that there may be traffic that's not HTTP that will be of interest to us. Let's look at our dest port. So some of it was over 80, which we've seen a bunch of, but look at this 63394. That's pretty weird. We're just seeing 3 events here. That's not as helpful. Let's do dest port. See if we have more information in the 80 stuff. In TCP. Not really. It's all port 80 anyway. I see we have a language class going on in chat. It's going very well. or muy bien, I guess. Yeah, this isn't revealing. So let's go back. Let's take a look at our Suricata stuff. We're mainly seeing state closed, flow. Yeah, nothing interesting here. I know that there's an upload defined, but we haven't found it yet. So where did we end? We had this refer, right? This Google.ge. So let's actually check that out. Let's use that as a... Because we have refer as a field. Do we not? HTTP refer. That's so funny. HTTP refer is spelled correctly in the field, but it's not in the actual header. Nate Edge. Nate X Edge. Thank you for the follow. Okay, so we found 11 events for this Google.ge and reversing them to see them in order. And what are we seeing? They're all GET requests, so we're just seeing kind of all of this get mangled. I think at this point, we would want to actually go to the end. Yeah, of course we would. At this point, we want to actually get on the endpoint and see what's going on at the endpoint. So we're no longer... Any opinion on the oh my god stuff, the ActiveX crap that came out recently? Yes, I do have some takes. They're not really hot takes. They're at best lukewarm takes, which is that the problem we're seeing is that Microsoft is trying to support 3 to 4 decades worth of backwards compatibility. And guess what? It turns out you can't do that without security holes. The fact that MS-HTML.dll still had support for ActiveX controls in 2021 is Fruit Loops. It's absolutely crazy. And I think it was very telling that you had that happen the same week that you had a vulnerability in a cloud product where they're pushing the edge of what they're trying to do to become a cloud service provider much more than they're trying to be a desktop software manufacturer producer. And I think Microsoft has been fighting this split personality for some time now, where they have kind of the Azure stuff. They're trying to provide everything as a service. Meanwhile, they're still trying to support decades of desktops that they've sold and need to maintain support for. For example, I think that the Department of Defense still has an extended support contract for Office 2007. Okay, so we want to get on the endpoint with this thing. So this is a whole new ball game. At this point, we want to look for our dest IP, right? And let's actually see if we can find some stuff in Sysmon. That would be quite helpful, wouldn't it? If we have win event log or come on. Well, let's look at just this and see if we can, right? Super zoom out. Source type, there's my Sysmon. That's what I wanted. All right, look at that. Once again, we're looking for spikes. All right, so some stuff went down here. And this tracks, by the way, with our time window, 9:45 to 9:46. I have no idea how to pronounce that. Pushelb. Pushelb. I don't know. But thank you for the follow. Look at these spikes. I love seeing stuff like this. Nice and obvious. One of the kind of red team mantras is to blend in with the traffic, right? This is not blending in. This is calling attention to itself. And if we have 1670 events, I want to zoom into this quite a bit. So awesome. Look at that. So you can see how the destination IP is actually the 2322. Now we're seeing stuff come in. And that actually might be something to figure out as well. Even if in our HTTP, we can stop, instead of looking for, we can look for source IP equals our 2322 63.114 as well. So once the shell was on the machine, did they pull from the same source? And it looks like they might have. We're looking at 1430 events. That's a lot of events, right? So we'll reverse it, and let's start by tabling it to URI. Dominic, thank you so much for the follow. Oh, wait, no, not source IP. I want dest IP. Well, that came out pretty clean. Why can't new followers? Why are new followers' names weird? You know what? They're just their names. It's not necessarily on them that they can't pronounce it. That's on me as much as it is on anybody. I'll never forget. It's so funny. Like, I think a lot of people started asking, like, why didn't you pick a handle that wasn't your name? And I was like, I don't know. People just call me this. There's no reason to come up with something else. Plus, it always seemed kind of funny to me. Like, no, just for me. Like, I have no problem with people choosing handles. It's however you want to identify yourself. But it was just like, it didn't make sense for me. It's I'm too square for a name like that. And I'll never forget, like, my first hacker conference. I went to Hope in New York, right? And somebody introduced themselves to me. It was like, "Hi, I'm Lord Nightmare." I'm like, "Are you?" Nice to meet you, Lord Nightmare. I was like, I can't. That's, you do you, but I'm just Taggart. That's fine. So we finally found this image that they pulled. Poison Ivy. Poison Ivy is coming for you, Batman. Oh, that was the name of the not the executable though. We found the image. I think we jumped ahead. Yeah, the name of the file that defaced the I'm Not Really Batman website. We still haven't found the name of the executable uploaded by Poison Ivy though, but that, I think we're going to see that in the endpoints. So if it's an executable, and we're looking at sysmon, right, in this time window, we're going to look for event code. It is event code, right? Event ID. Not a pipe. We're just going to look for event ID equals 1. And I want to see the table. We're going to table time, and we should see image. Yes. Good. What? All right, let's get rid of the event ID, just in case I did something weird. That's unhelpful. System. Okay, so the syslogs, the sysmon logs aren't parsed super well, is what I'm getting from this. Only event ID 3. You know what? Let's zoom out a little bit. I think we are too close. Yeah, see, I think these were all event ID 3. In fact, to confirm that, this is something that we should always do. Time chart count by event ID. Give us a really nice, especially with sysmon, give us a nice visualization of what happened when. Are you for real? It's all network connections? Sucks. Now here we go. Taking out the source IP, which makes sense, of course. Taking out the source IP, you know what? Let's actually back this up a little bit. My issue here was the parsing. So the problem here was the computer. I want to use the computer rather than the source IP because looking for that IP address was messing that up. Let's try that again. That's what's up. Okay, so now we're seeing event ID 3s, but we're also seeing 7. Interesting. Event ID 7. Image loaded. So this might happen. This event is disabled by default. That's why it wasn't at top of mind. Image loaded is indicated in which the module is loaded, hashes the signature information. Okay, thanks for sharing, Hepsi. Let's look for image loadeds then. I do actually want to look at event ID 1 first because I want to see process created, and then table time image command line if it's there. Nothing. I'm looking right at it. Oh, cute. What is happening? Oh, because it's time charted. Duh. There we go. Oh, thank you so much. Yep, Threat Hunters Unite. All right, so now we're seeing this is in reverse order too. So let's, or it's actually, let's look at this in chronological, and we'll jump to like 9:45 and see what we're looking at. Yeah, come on. 21:25, 21:40, 21:45. Okay, so we've got PHP CGI, which is doing some stuff. This looks weird, by the way. This is a Joomla named pipe thing. PHP CGI, secure embedding. What else we got? Check out the hack list. You sure can. There's a bunch of us. Not so many blue teamers, but we're few but mighty. Okay, so if we're just looking at process creations, you know, I'm seeing .3791.exe. This is the first thing I see that looks like a payload that isn't something built in. Got him. Now, luckily, I can get the hashes in the table as well. Thank you so much, Sysmon. So let's go find that 37. Was that on page 2? 3. Let me go to 100 per page. 3791. Yeah, give me that MD5 hash. And while we have it in our clipboard, let's virus total it. Huh. It was cmd.exe. Oh, I copied the wrong hash. Whoops. I was like, what? Let's try that again. I did not. Hey, there we go. That's what I was expecting. All right, so we found 3791.exe. What is the MD5 hash? This attack used dynamic DNS to resolve the malicious IP. What fully qualified domain name is associated with this attack? So we're gonna have to look at our DNS logs, I'm pretty sure. Unless it's in here. Oh, yeah. There it is. I didn't... Oh, God, thank you, Sysmon. I didn't have to go anywhere. Just look right here. Thanks, NSLookup. What IP address has Poison Ivy tied to domains that are pre-staged to attack to win enterprises? Hanks, 25320. Thank you so much for the follow. All right, so let's see. We're looking at this, coming to the end of this one here, which is good. I think that'll be a good stopping point for today. But so now that I have this domain, right, I have a couple of things that I can do. The first would be maybe just look this thing up. I've got virus total open, so let's see what's up, right? And let me sign in real quick. And let's do that search again. And let's see what the network looks like for Jumping Crab. Hey, okay, so do we have ourselves some IPs? Good Lord. We have many. I might also check gray noise. I just like the gray noise interface. Oh, thank you for the... Thanks, Ogosoro. Good looking out. I think I need to give it an IP first. So we're seeing a lot of domains here. I'm going to check out Cisco Talos. Thank you so much, Captain Marvel. Yeah, is it neutral? It's unhelpful. So there's the 2322 that we saw, and it's from Amazon. So, okay. Is it still the 2322? Is it just this again? Yes. Okay. Based on the data gathered from this attack and common open source intelligence sources for domain names, what is the email address that is most likely associated? Well, we actually should be able to pull this from the whois, which we saw somewhere. Yeah, show me the historical whois. (2021). These are too new. All right, there's the IP. No more relationships there. Let's go back to gray noise with the IP. Nothing. Killing me, Smalls. Okay, here we go. Now, the problem is that this is all old stuff, right? So if we're asking for what is the email address that is most likely associated with the Poison Ivy APT group? In 2019, we had these are all the whois stuff is all restricted. We have Lilith.jumpingcrab. Let's see if there's anything in historical whois for that. Not so much. And I'm looking for older data, right? It's like, because this was done in 2016. Community doesn't have anything for it. I might try abuse IPDB as well, just in case. Aaron, maybe? I am not a robot, as far as I know. Oh, boo. It's one of those. Who was? That's cute. All right, I'll use the IP instead. Come on. Ugh. I feel like it should be in VirusTotal somewhere here. We're just not seeing it. Maybe it's not in Whois data. Maybe it's someplace else. Doesn't have any relations. You sure about that? Okay. This EXE. No. Amazon, 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 Amazon. We should use the set MITRE attack relating APT group. You're going to have to give me a MITRE attack number. No, we're trying to associate it to a specific, email address, basically. I don't want to. Just Googling is not going to be super helpful. Not what I wanted. Because it's going to give us back. All right, Alien Vault, what you got for me? Hey, Alien Vault came through. PoisonIvy.com. Two cows for the who is. Let's see if there are any other IOCs here. All domains. PoisonIvy.com as this. But now we have another IP address to go after, which might actually help us out. Whoa. Except no, not really. Hey, Nemo. We are searching Poison Ivy. What is the email address that is most likely associated with the Poison Ivy APT group? Hang on a second. Oh, no. What is the email address that is most likely associated with the Poison Ivy APT group? Oh, wait a second. I might be thinking about this wrong. I might be thinking about this. Because we have email. I wonder if there was an email that came in. No? Do we not have email? Never mind. All right, we're going to move on. GCPD reported that TTPs for Poison Ivy APT group, if initial compromise fails to send a spear phishing email. Oh, this malware is usually connected. Using research techniques to provide the SHA-256 hash of this malware. Okay. Getting some questions about, do we search for 25 port? Let's just go back, remember, and we're going to do just a chart count by source type to see what we have coming into our logs. It's port 25, right? Let's see. So I don't have email logs, okay? Regardless of port, right? I don't have IMAP, I don't have SMTP, I don't have POP. So I can't look at anything there. Gaming asset, thank you so much for the follow. So I have to use open source intelligence, basically. I'm not going to be able to find email data in my own logs. Instead, look at these exes. Let's actually go back to our IP. So we saw that there were some exes connected to this. Check.exe. Miranda Tate screensaver. That's cute. Let's see if this is the one that they were looking for. It was. I wonder if that gives us any more information. It doesn't have any relations. Okay, moving on. What special hex code is associated with the customized malware discussed in the previous question? Customized hex code. I'm going to go with this. What does the hex code decode to? Now we go to CyberChef. Which I really should just bookmark, huh? Anyway, from hex. Okay. I'm annoyed about this email address. Right, we found poisonivy.com. Maybe it's on VirusTotal. Well, I thought we checked it, but yeah. Is this what they're after? No. SMTP. Getting somewhere, maybe. Oh. Duh. Okay. Of course. Uh. Nope. That. Nope. Sorry, I'm getting a little punchy here at the end of the stream. That's what I wanted. Yep. But there's only a Got it. WayneCorpInc.com, I think, is what had it. If we go back, if we search for Wayne Corp Inc. No? Well, at any rate. What? Whatever. I don't know why that's not doing it for us, but I feel like we did a pretty good job hunting that down. I guess we could just also do like at poisonivy.com, huh? Oh, except Lillian at poisonivy.com. Oh well. Yeah. All right. Well, friends, I think we're going to call it for today. And next time, we will finish up the second part of this, and then we'll move on to some other stuff after Splunk. But I think learning how to use Splunk in this deep way is really, really important. Some personal news. I am taking an exam this weekend, and into Monday, I'll be taking my Certified Threat Hunter examination from eLearn Security. So I'll have a review on it after I finish, and hopefully everything goes well. Thank you so much for everybody hanging out. Let's see who's on from the hack list. Send you guys someplace fun. Okay, looks like Security Live is on, so that's always a good watch. All right, so friends, thank you so much for hanging out. Until next time, be good to yourselves. Yeah, hey Czar, finishing up now. Be good to yourselves, be good to each other, and I will see you on Tuesday.